Good morning. Today I will be solving integral of ex sine x dx. So we have a product of an exponential and sine, which is a product of two functions of different type, which we usually solve by integration by parts. And you can do it by integration by parts, but you will have to do integration by parts twice. So another technique to solve this type of integrals, which is exponential times sine or cosine, it's the same manner, you can solve by the same manner, is using tabular integration. But it's not the same version of tabular integration where we have a polynomial, as we have seen in an earlier video, because when we have a polynomial, we put it on the left and we derive until reaching 0. Here we do not have a polynomial. We do not have a function that we can derive until reaching 0. So we are going to use another version of tabular integration. So what we do is that we put the exponential on the left and we derive it twice. So the derivative of ex, it's ex, and again it's ex. And we put the other function, which is sine here, on the right, and we integrate it twice. So the integral of sine is minus cosine, and the integral of minus cosine is minus sine. And so we join the first to the second and second to the third, and then these two would be multiplied together and integrated. So basically what we are going to have here is I would be equal to a plus ex multiplied by minus cosine x. So minus ex cosine x minus ex multiplied by minus sine x, which is a plus ex sine x, and then plus integral of ex multiplied by minus sine x. So it's minus integral ex sine x, which is I, the integral that we are trying to solve, which is I. So I will have I is equal to, I took ex into factor between these two, so it's ex, a factor of sine x minus cosine x, minus I. And I'm searching for I. So I take minus I to the other side, I will get I plus I, which is 2I, equals ex factor of sine x minus cosine x. And finally, I that I'm searching for would be half ex sine x minus cosine x plus a constant c. Now, let's do another example, which is a bit more complicated, which is integral of e2x sine 4x. So we are going to use the same version of tabular integration we just used earlier, where we put e to x on the left and we derive twice. The derivative of e to x, it's 2e to e to x, and we derive again, so we get 4e4x. And on the right, we put sine 4x and we integrate twice. Now the integral of sine 4x, it's minus 1 over 4 cosine 4x. And then the integral of cosine 4x, it's 1 over 4 sine 4x, so we get minus 1 over 16 sine 4x. I used these two rules here to find the antiderivative of cosine kx and sine kx. I used them here. So my integral that I'm trying to solve would be plus e to x multiplied by minus 1 over 4 cosine 4x. So it's minus 1 over 4 e to x cosine 4x minus 2e to x multiplied by 1 over 16 by minus 1 over 16 sine 4x. So we get plus 1 over 8 e to x sine 4x. It's written here. And then a plus integral of 4e to x multiplied by minus 1 over 16 sine 4x. So it is minus 1 over 4, because 4 times 1 over 16, it's minus 1 over 4. So minus 1 over 4 integral of e to x sine 4x, which is I. Always this integral would be I, always. So we take minus 1 over 4i to the left-hand side, we get I plus 1 over 4i equals what remains from these two, which is minus 1 over 4 e to x cosine 4x plus 1 over 8 e to x sine 4x. And we are searching for I. Our unknown is I. So I plus 1 over 4i, it's 5 over 4i equals to the same thing as before, which means I would be equal to 4 over 5 factor of minus 1 over 4 e to x cosine 4x plus 1 over 8 e to x sine 4x plus a constant c. And we can take e to x into factor from these two, and we can expand, we can put 4x inside the parentheses, so we get e to x, then minus 1 over 4 multiplied by 4 over 5 would be minus 1 over 5 cosine 4x, and here we will get 1 over 8 multiplied by 4 over 5, it's 1 over 10 sine 4x plus a constant c. And this is our final answer.